you did not know, the NFL season started just a couple weeks ago. Week 3 begins tonight. And yes, the Baltimore Ravens are 2-0 for the first time in several years. We are very excited about that in the Keeler household. And we get a thumbs down from Bill Petersen on that one. We will hear about his preferences in just a moment. It's probably another bird team, I would guess. If you don't know anything about the Geo-Institute, after you watch this program today, you should head over to geo-institute.org. And there you will find out so many things about us, including that we are a technical society with about 12,000 members, most of whom are geotechnical engineers and or geologists, and that we are part of the American Society of Civil Engineers. Of course, if you like what you see today, and I feel very strongly that you will, you should click like, subscribe, and get notifications, and we will let you know every time we post something to the YouTube channel. A little bit about GEOSTRATA Extra. GeoStrata is the Geo-Institute's member magazine. We publish 6 issues a year, and every time we do that, we have an episode of GeoStrata Extra. It is designed to go behind the article, some stuff that maybe didn't make it in, some stuff that the author was thinking about when they put the piece together, and all kinds of detail for your hungry, voracious minds to consume. Today is a little bit special because this article was actually in GeoStrata about 2 years ago in the fall of 2021. But since it's the start of football season, we thought, what better topic than the perimeter wall at SoFi Stadium in Los Angeles, home of the Rams. And so here to talk about that today is Susie Rafalko from the Reinforced Earth Company. And here to interview her about her piece in GeoStrata is Bill Petersen, GeoStrata editor. Bill, tell us who your team is and what's the outlook, and then I guess we're going to get to some questions and answers. Thanks to both of you guys for doing this today.
Well, my team is obviously the Eagles, and I like their chances this year. We'll see what happens. They almost did it last year. Anyway, so yeah, back in October, November of 2021, we had an issue with the theme amusement and event space geotechnics. And in that issue, there was an article called the SoFi Stadium Perimeter Wall that was written by Jason Zwickel, who is the marketing and communication manager for the Reinforced Earth Company, better known as RICO. Our guest, Susie Rafalko, was a design engineer for RICO on this project, and we will be interviewing her today, as Brad said. I'm Bill Petersen. I'm a principal consultant with Rimkus in Philadelphia area. Longtime member of the GeoStrata editorial board. So shortly after working with Jason on this article, Super Bowl 56 was held at SoFi Stadium in February of 2022. So at our neighbor's Super Bowl party, I was dropping a lot of trivia about the wall construction, which, by the way, you cannot see during a television broadcast of the game. So obviously they were no more interested in that than they were the dumb commercials. But what people were interested in is sort of a key element of this project is the fact that the stadium elevation had to be pushed down about 100 feet to avoid interfering with LAX airspace. And I finally went and looked at a map this morning and was surprised how close it actually is. The stadium is roughly 1 runway length to the east of the edge of the runways at LAX. So you could see where there'd be an issue there for a tall structure. So yeah, it's like a lot of geotech work. It's a little ironic that you've got such a massive construction project that's really hidden from the public view. And we'll revisit that theme here a little bit during the interview. So to introduce Susan, she's a senior engineer in RICO's corporate engineering department working in Denver. She's been involved in the MSC wall industry for about 15 years. In this role, she assists other divisions of RICO's engineering department nationwide on complex projects and geotechnical challenges. She has both a bachelor's in civil engineering and a master's in geotechnical engineering from Virginia Tech, is licensed in 16 states, and she will talk a bit more about her specific role on this project. So before we get started, I'm sure a lot of you out there today have been involved in MSC design or provided geotechnical recommendations for MSC designs. So there should be some questions. If you think anything along the way, just type it in the chat box. We'll try to get to as many of these as we can at the end. So just to sort of start out, Susie, could you just give us sort of a 30,000-foot overview of the project and what your role in it was?
My role, I was the signing PE for all the MSC wall plans going out the door. So reviewing the design, engineering, and calculations for everything. As for the design, you kind of gave the overview of it. We created, the MSC wall created the bowl for essentially the stands in the stadium and the field, since it had to be, set into the earth. There's a lot of details to it, but in general, that's kind of where we're at.
And you were working with Kiewit on that as the general
Yes.
contractor.
We work for contractors typically, and Kiewit was the contractor on this job. They did a great job in constructing it.
Do you have an idea like what the overall, roughly what percentage of the total project cost was the perimeter wall?
We were about less than 1% of the cost of the project, and I think the project was about $5.5 billion. So overall, we were pretty small part of it, but cost-wise.
Interesting. So what all did Rico contribute to the project?
So Rico, we do design and engineering, but we're actually a material supplier as well. So not only do we provide plans for the MSC walls, we also provided the facing, the strips, and the accessories for it. We also provided some site assistance during construction as well. Okay.
So again, I'm sure a lot of you are pretty familiar with how MSCs work, but maybe for those that aren't, could you just give us a quick review on how the technology works?
Sure. MSC walls, it stands for mechanically stabilized earth. It consists of a concrete facing. Typically, we use 5.5-inch thick panels. On this project, we used up to 8 inches due to the height of the wall. And then it's typically, and he's showing a cross section of, for this particular project, was a bit unique. Another large part of the system is the soil reinforcement. We use discrete steel strips. And on this project, we use different thicknesses, again, due to the height of the wall. Our strip lengths varied from 9 feet to 120 feet. This is also a very specific, specialized strip layout. Typically, it's a rectangular section with the strip lengths about 70% of the wall height. And I'm sure we'll discuss the details of this a bit later, of this particular layout of the strips. And then there's a structural earth backfill that's used, and it has certain parameters that the contractor needs to make sure it meets, for things like to prevent accelerated corrosion and things like that. On this project, we had some challenges with what material to use because because they were excavating so much from the site, they wanted to reuse a lot of the material. So some of the silty sand on site, at least initially, because it kind of changed through the project, at least initially they had about 70% of native soil they were blending with a small grain gravel they called bird's eye, and that was making up 30%. So that was initially what we were using. And then as the project progressed, there were some changes in that depending on what they kind of came across and what they had left to use. So that's kind of the general kind of makeup of the MSC wall. This technology has been around for the technology was patented about 60 years ago. And that was by our founder, Henry Vidal. He invented the system and patented it. It's our 60th anniversary for that this year.
Great.
This is just showing some of the strips, those 2-inch wide strips, those discrete strips. And actually, these are not the full length of the strips for this section of wall, and I can tell because there's a bolt hole at the end of it, so they're actually going to connect more length to it. Our strips are limited to 32 feet in length due to shipping reasons. They can't put longer strips on a flatbed truck more than that. But you can see our panel facing up there. That's our cruciform shape, which is kind of a plus sign, I guess you would call it. And that shape is only used by us, actually. But for these bigger walls, we have so much historical data with using this facing, so we feel very comfortable using this facing type for tall walls.
Okay. And what was the governing design code that you had to use for this project?
We used ASCE LRFD, and I think it was year 2012 during the design.
Gotcha. Okay. Why don't we go through sort of an overview of the geometry and layout of the walls. Got a nice graphic here showing a plan view to help get people dialed into what was built out there.
Yeah, there's a lot going on in this. So you can see a general oval circular shape around the field. That's the 100-foot MSC wall. And technically it's 110.5 feet, I think, because there's 100 feet of MSC wall, and then on top of that, there's a cast-in-place wall that's 10.5 feet tall. And that was very useful because it allowed about 10 feet of the top of the wall to put utilities, anything that would need to be accessed at a later time. So you don't have those metal strips going back. So it gave a better, easier access for maintenance stuff and things like that. You can also see that there's a whole lot of piles going on. There's things that we call blade columns. I believe that was for the roof. There's also piling that was for stairs, escalators, I believe a restaurant at 365 on the right-hand side there. There's various canyon walls, probably more for aesthetic. Well, maybe there's reasons for, maybe there's a stairway up them or something like that. But there's a lot of smaller walls on top. That was probably more aesthetically pleasing. There's also a couple of tunnels in there in the lower right. You can it's kind of hard to see, but I think we have another visual that you'll be able to see it better. But there's a permanent tunnel we had in there for VIP access and players to kind of come through. And then we also had a temporary tunnel up to the upper right for access for the contractor.
Okay, so I'm on the aerial now. Now, when you say canyon wall, what exactly is that referring to?
So that was something it's just what we were calling it during the project. I don't even, these things progress in terminologies, but
right. So you won't find the definition in ASCE anywhere.
Yeah. So, I mean, even if they're, even the canyon, you think of two walls going down a deep gorge or something, but it was really just these tiered walls that were kind of going up the side of the stadium probably is what it looks in its final condition. And a lot of them you can't even see in this aerial photo. But yeah, it was almost any wall that was like up and above the main bowl MSC wall.
Okay.
So that's what the canyon walls were really. But there's a ton going on in this picture. But May can point out a few main items here. But there's a concrete structure kind of coming off the bottom. That's the permanent tunnel. No, like further to the right and kind of going away. Yeah, so that's the permanent tunnel. Again, player access and VIP access. The hole in that tunnel was about 35 to 50 feet, so it wasn't small. There's also another, you can see kind of a roadway coming down into the site there. And so that was a temporary ramp for the contractor, and we had some temp walls around that. We also, there's a lot also, not even like in the middle of the site, but you can see a lot of storage kind of going around on other parts of the site. If you look in the very upper, I guess if, it's kind of a diamond shape. If you look at the top of it, there's actually rows of panels up there where the contractor was storing our panels. You can even see stacks of reinforcing strips if you know where to look exactly. And in the area
up in here.
Yeah, so that's all the precast panel storage on site there. So they were pretty well organized, Kiewit. They really had their stuff together. I also think we didn't have anything to do with this, but the lower right too, I think, is the batch plant they had for the blade columns. So yeah, if you can kind of zoom into this picture. And by the way, this picture was provided to us, or we had West Coast Aerial take this photo for us. But I think it's just kind of really an amazing photo to kind of look at. Yeah, you can zoom in. There's a lot of detail in this photo.
Yeah, it's a good shot. Okay. Yeah, so for a 100-foot deep excavation, for me anyway, kind of begs the question, what was the general geological conditions at the site?
And I guess pointing out real quick, just our wall, because you can actually see it here. But
Oh, okay.
yeah,
Oh, right here.
we kind of like missed that point, but that's not the top of the wall either. There's well, that in that section it is, but it'll go higher. You can see it's kind of staggering up and down. So that's not even the final height of the wall there.
Okay.
And I think you were asking about the geotechnical.
Yeah, just, where the general soil conditions, depth to rock, things like that.
Yeah. This site was previously I guess, a racetrack, the Hollywood Park racetrack. So there was about 25 feet of man-made fill on the site. And below that, there was a lot of alluvial gravel, sands, and clays, down probably to a depth of about 80 feet. And then below that, there's the Lakewood Formation, which was kind of partially marine and non-marine deposits, pluvial like sands and silts. So which was nice for them because they're like bedrock wasn't really encountered. They did some borings down to about 200 feet. So to find this site where they could kind of go down and dig and not have to excavate bedrock was probably like really worked out for them in the end, I feel like, because I don't know how that would have been a huge headache to have to excavate rock instead of soil.
Absolutely. Were there any issues with the just the overall soil parameters, shear strength, for example, that had an influence on the design of the walls, the base width and strip length, things like that?
So again, it was a really advantageous site for the MSC wall design because we were about 100, our base of our wall is 110 feet down from existing. And at that point, the blow counts are about 50 or more, which was terrific for our design and for the contractor. What that means with having a blow count of more than 50 is we can use this trapezoidal strip layout. And I think that's what we were showing initially with that typical section, where the strip lengths are shorter on the bottom and can go up. We can, when the ground is that competent, we can use shorter strip lengths around the order of 40% instead of the standard 70%. Now we have to make them longer on the top to compensate, but that really helps the contractor when they have to excavate, because their excavation is going to be sloped, right? It's going to be, I think on this one it varied depending on the depth, but maybe 1.5 to 1 or something like that. So it really cut down on the amount of excavation that was needed for the project by being able to have this really competent foundation allowed for that. And a lot of the times we have contractors asking if they can use this design because it's in FHWA. And a lot of times we have to tell them no, because they don't have that competent foundation. So this design really was beneficial to us.
Interesting. Yeah, I've never actually seen that trapezoidal cross section before. So was dewatering necessary at all at that depth?
So, and again, like it ended up being a really good site for them because they had some perch water that was above the base of the wall, but I don't think that caused much issues for them. But the design high groundwater was at elevation 0, which is about 38 feet below the bottom of our wall. So again, as far as the site went, it was kind of, it worked out really well for this application. The one problem they did have, though, was there was a few months there during construction where, California either doesn't rain at all or it rains a lot. So they had a few months where I guess it just poured, and because it's like a big bathtub in the ground, well, we usually say, hey, like slope away the water from the wall, but how do you do that, when you have basically dug a huge hole in the ground?
Right.
how do you keep the water out? So they had some serious issues kind of dewatering that for a few months when it was raining pretty heavily. But outside of that, I believe they didn't have to.
Good. So I mean, the depth of this thing, obviously the choice of retaining structure alternative probably played a huge factor in cost, schedule, etc. I know reading some of the other contractors entertained some other alternates, and maybe Keywood did as well. You want to just talk a bit about why the MSC system was chosen and what advantages it offered?
Yeah, I think they were looking at secant pile walls maybe briefly, but the MSC walls are very good in high seismic locations. I mean, they're backfilled with soil, like it's part of the structure, so it dampens seismic loads very well. So that was one of the big reasons why the MSC wall system was chosen. But on top of that, because we precast the panels and you don't need to be casting any concrete while you build up the wall, the speed in which the wall could be built was also a big advantage to our system. So it was really, you know, the cost, the performance, and schedule that really kind of sold Kiewit and the design team, on using MSC walls.
And probably because it's built bottom up, it got the excavation down faster so they could start working on the interior of it as well, I would guess. So we're going to get into some of the design challenges. I mean, because of the seismically active location, as well as the height, I'm sure there were some seismic issues had to be a major consideration. You want to talk about that a little bit?
Sure. This is the huge part of the project. And again, like I said, MSC walls perform really well in seismic events. And so like there's been obviously a lot of earthquakes in California. We have a bunch of walls out there. So some of the more significant earthquakes that have happened were probably in the late 80s, early 90s, with magnitudes of about around 7. And we've had dozens of walls kind of inspected after these events, and really there's no significant distress that's been noted of them, because we'll go out and check on them with Caltrans. And I think it's only been very superficial damage. So we have a history of being able to show that our walls perform well outside of modeling and things like that. And for MSC walls, again, like because we haven't really found that many issues, it's a pretty straightforward design, even with the high PGA of the site, which was 0.63 G. It's really not all too challenging for us to design to that. It's a strength-based design. So that's pretty straightforward. But what really was the bigger challenge in all this was the obstructions in the backfill and the size, because the strips were so long due to the wall height. In this picture, you can kind of start to see maybe what I'm going to start to get at, but like if you skew a strip to get around a pile, and those are the blade columns there actually. But if you skew the strips to get around a pile, you've kind of opened up this zone where it's not reinforced. And on a smaller wall, maybe this zone would be kind of small. We don't really have to worry about it. But on this project, these strips are probably like 100 feet long or so. So by the time you skew them and are at the end of the strip, you have this huge, huge gap. So we did something that we don't typically do on this project. You can see those dashed lines, and those are actually reinforcing strips not connected to anything. But like just mechanically stabilized earth technology, you really actually don't need it connected. So that's still doing a lot, even though it's not connected to a facing or anything like that. Another detail worth noting too is that there's that portion on the right where you can see all these equal dimensions, is that we typically have, can you see that?
Let's see.
It's kind of like fanned out as it's going around the corner on the right.
Oh, up here?
Yeah.
Okay.
So typically we have our reinforcing strips. If there's no obstructions, we have just our strips perpendicular to the panel facing. But again, if we did that here, it would have created really wide kind of zones of unreinforced soil. So even when there was a kink in the wall or things like that, we had to be very cognizant of that and make sure to spread out the reinforcements like equally as it kind of is showing.
Right.
Also another thing to add to all this that's not quite, well, I guess some of it's seismically related, but the blade columns were isolated from our wall. That's why there's two circles there. The outer circle is a casing, and then the inner circle is the pile itself. And there was just, I believe, yep, that's a good picture of it. And actually, you can see the strips. What am I going to talk about first? The casings were there so that the two structures didn't really interact during a seismic event. That the roof structure would move independently of the MSE wall. So that's why they had isolation casings. There were other pilings for other things like the restaurant and some escalators and things like that that didn't have these isolation casings. So in those cases, we'd have to look at what effect each structure had on the other. And for those structures, we would have to account for additional lateral loading on our wall. But things like this, we didn't need to because it was so isolated. This is a picture of this in real life. And you can see that this is one of my coworkers. His name's Morgan, and he's standing right next to those strips that aren't connected to anything. So that's just kind of showing behind one of the isolation casings that's getting blocked by, so it's blocking the reinforcements from the paneling, and that's just not connected to anything. This is also a pretty good shot of our splice connection. Like I mentioned, the strip lengths are maximum of 32 feet. So this is just kind of those double bolted connections on the ground there. That was the connection we used. It's 2 splice plates and 2 bolts to kind of connect the 32-foot long strips to make those 120 or whatever it was.
Mm-hmm. Something that jumps out at me in this picture is how clean that compacted fill surface looks. It looks like a pool table.
Yeah, I mean, Kiewit's really good at what they do. And yeah, they did a good job, really. It's nice to look at.
Good stuff. Anything else on this slide, or are we ready to move to the next one?
If somebody's really paying attention, they'll notice that the blade columns are not centered in the isolation column casings. Oh, yeah. And I believe there was 3D flak modeling done. We didn't have much to do with this, but from my understanding of it is that there was flak modeling done, and so things are moving more in one direction than the other. So I guess relative to one another, MSE wall and the blade columns, the blade column was expected probably in this picture to move to the left more. So that's why it wasn't centered, because it was eccentric. I can't talk. It was, yeah, loaded. So
that's interesting. Okay, well, you had mentioned the ramp that the contractor had to get down into the bowl. I don't know if there was anything else in this slide you wanted to point out.
Yeah, I mean, I think there is. So to get to the bottom, we helped the contractor with that by providing 2 walls to kind of, go down so they could use the ramp. And these walls, if you've noticed, it's a wire wall on top and a precast paneling on the bottom. A lot of the times temp walls are just wire-faced walls. It's just more cost-effective that way, right? Mm-hmm. But these temp walls, especially at the max height, were still about 110 feet tall. So at that height, you're starting to max up the temp wall system. In addition to that, they had a lot of big construction equipment kind of running up and down. And we do this on mine walls. So you're afraid that they might run into the facing at some point, doing whatever they need to do. So a lot of the times in those kind of applications where there's going to be a lot of heavy equipment running around, we'll put the precast paneling down there. But we see this a ton. We do this a lot on mining sites.
Okay. So the MSC wall, I mentioned earlier how, watching a game on TV, have no idea it's there. What can we see in the constructed say? Well, I guess this is still under construction. Oh, this is part of the ramp.
Yeah,
Yeah,
so that's just a different view of the temp wall, just more straight on and
Okay.
probably getting towards the top of it, but you can just see how tall it was, but just another viewpoint.
Right. So I think you mentioned that there are some places within the final constructed condition of the stadium where you can actually see the wall.
So a lot of it is what is actually shown right here. So our
Uh-huh.
cruciform panels that create the majority of the bowl of the wall, you're not going to see. And what's in front of it is, I guess, all the amenities and things like that in the stands. And you can kind of see though that in this structure, this will be the final structure coming in front. But there's a gap between the MSC wall and the stadium structure. That's not the roof. In case, again, seismic load, seismic moving, if they're not in sync, there's still a gap between the MSC wall and the rest of the interior structure.
So this portion of the wall here was still under construction, I'm guessing, due to the height back here behind the structure, or is
Yeah,
this the
for
final
sure.
height? Okay.
No, I think it would probably be closer to what's more in the foreground there. Was going to be, and that might not even, that might be the top, actually, where they have that brackets. Usually I think they have the brackets when they're about to cast in place, form something.
So that superstructure was going up pretty fast, and you had to coordinate your work right around them, looks like.
Yeah, I think, I mean, I can't really speak to that much, but my guess would be it actually, like that wall facing is kind of a nice line of, because all of our construction's done in the back, right? So, and they're doing everything in the front. So that actually kind of worked out nicely for them that they could kind of work on it concurrently.
Right. And then I think you were saying this is called was it the North Canyon Wall? This is something that's visible
Yeah, so
right now.
I believe the only part of the wall that's truly visible is this section of wall, which we were calling the North Canyon. And it's actually not that cruciform shape that I had mentioned earlier. It's our rectangular panels. And this is also a pretty aesthetically architectural special design that we don't typically do, but they wanted a certain look to it. And I think it turned out pretty good. But it's a little different because almost every single row there is kind of set back a few inches. So kind of has this nice tiered look. We also typically stagger our panels, but there's like defined rows instead because of that staggered. But yeah, so I think this is potentially the only bit of the wall that you could see. But if you're not in the stadium itself, I think this would be hard to see from any like shots of the football game because I think it's kind of parallel to how the camera would shoot it. So I don't.
Yeah, I was a little disappointed during the Super Bowl that couldn't get a peek at the wall, so I stopped talking about it.
You gotta go in person to see it, I think.
Yeah, one day, maybe if the Eagles go this year, I'll get a ticket. So one of the things I really liked about the article is how he incorporated a lot of football themed analogies to just sort of give perspective to the scale of this project. One of them was, for example, the cumulative length of reinforcing strips used was over 1,500 miles, which is about the distance the Rams traveled when they moved from St. Louis to Los Angeles. Do you have any other fun facts about the scale of the project?
I mean, this wall, if you include the cast in place wall on top, was about 110 feet tall. It is one of the largest, tallest walls in the U.S., but SeaTac Airport is definitely our tallest in the U.S., and that kind of goes at 135 feet. But it is a tiered wall, so there's sections of it that are set back, and it's not a straight vertical face. Our tallest wall in the world is in South Africa, and that's at 148 feet. But that one does have a vertical face. And I believe both of those are that cruciform facing panel. Again, we just have a lot of experience with it, so we like to use that product for those types of applications.
That South Africa wall, is that tiered, or is that 148 feet straight up?
It's straight up, it's vertical. So
wow, what was the application on that?
I couldn't tell you.
Oh, that's okay.
Sorry. Yeah.
No, that's
Um, And then I guess
Um,
as far as the strip lengths go, to the 120-foot maximum strip length that we used is that, I mean, it's long, but like I said, because we have these other walls that are very tall, it wouldn't have been the first time we used a strip length that long, probably. So, but yeah, still pretty impressive though, at the end of the day.
Sure. How long did it take to build the walls?
It took the contractor about 7.5 months. And then the main wall, I believe, and then those various other little ones maybe are topping things out. It kind of took maybe another year to complete it.
Okay. So you showed some of the like the material laydown areas for panels and whatnot. So with just the sheer amount of the quantity of panels, where were they fabricated, and were there any logistical issues with getting that amount of material to the site?
Harper Precast cast the panels for this project. They're based out of Utah. They do a lot of our Utah projects for us. They're a pretty great precaster. And luckily, Kiewit kind of did a great job managing stockpiles and storage on the site. And I think they had maybe about 5 acres worth of space dedicated for the storage of the panels, which again, we kind of pointed out earlier. So yeah, I think Kiewit just did a really good job about kind of managing all that and dealing with it.
So were there any issues with wall performance, either before, during, or after completion of the construction?
Yeah, no, I don't really think there was, and it's worth mentioning that we had there was a small earthquake that had a magnitude of 5.5 that happened a few weeks ago, or maybe a month ago, during the hurricane. And so as far as we've seen the wall perform fine and the structure perform fine in general. So looks like it's doing what we intended it to do.
That's good news. All right. Well, that was the end of my questions. I think the timing worked out pretty good. We have had a couple of questions trickle in so far. The first one is, do the plus-shaped, I guess that refers to the cruciform panels, have the same differential settlement tolerance as square panels?
Yes, they do. They have a differential, like per ASCE, they have, based on the joint width and the panel size area, like there's certain limitations to that. And for the square and the cruciform, it's 1%. Like you can go up to 1% differential. And you would ask that question, but we have a ton of history with the cruciform shape, and that's been proven that it functions the same as the square in that application.
Right. Okay. So the other question, I will sort of preface this by saying that we did discuss previously that you guys really were not involved in the geotech investigation or external stability issues. So this may or may not be something you can speak to, but I'll go ahead and read it anyway. Was there any concern with the silt/sands softening during excavation/stress relief?
I'm not sure if I understand the question fully. The excavation was kind of done, slope down construction. They kind of did an excavation. And yeah, I'm not quite sure what the point of the question is, if it's of the foundation remaining or if the reuse of the material, but
I think he's saying it like during, maybe because it's such a deep excavation, when the material was removed, was there a concern that stress relief could cause some kind of softening or loosening at the, the foundational level for the walls? But that's probably more of an external stability issue.
Yeah, I mean, the geotech usually comments on, subgrade prep and things like that. But based on the geotech report, they were there was commentary about, you know, this is a good foundation. Settlement was minimal. We didn't discuss that, but I mean, for a 110-foot wall, settlement was expected to be like 1.5 to 3.5 inches of settlement, and bearing capacity was like crazy at like 35 KSF. So,
Wow.
you know, if they had any kind of, and that was strength 1 bearing capacity or bearing resistance. So, you know, if there was any expectation of things softening, it don't think it made much of a difference for
Yeah, I
what
think
we used
you
it
were
for.
saying it was like 50 plus N value material below the footing.
Yeah.
So if they let you go with that trapezoidal shape, there probably wasn't too much of a concern with that. Let's see. Got another one. It's to expand on the question. You're relying on blow counts of 50 in the foundation below the MSE walls. Are you sure you will still have that bearing capacity? Oh, I think that was more or less of a clarification on the prior question, and maybe we addressed that a little bit.
Yeah, I mean, it's the we're not the geotech on the project. We come up with bearing pressures and compare it to the bearing resistance. So we have to know a little bit about it. But again, if the geotech gave a 35 KSF bearing capacity or bearing resistance, I should say, like it's still pretty good stuff. It's really good stuff, you know.
Yeah.
So we didn't do any kind of analysis on that kind of side of
Right.
things.
You wouldn't be too concerned with what happens outside the box. I know that's what we
Yeah,
should be
that's
told with
we designed the box and that's about it. So
just up to the edges. Looks like that's all, unless Brad's seeing anything else, to which he just said no. So I guess that will bring us to a conclusion. Very interesting subject. We appreciate your time and participation.
appreciate being invited on to this format.
And that was really good, guys. Thank you so much. I like case histories because sometimes you've actually been to the places and I don't know, it's just a lot more relatable. So it's a lot more fun for us too, I think. This was a great one to do for the start of the NFL season. So thank you guys for figuring this out and doing a great interview. For all of our viewers, if you liked what you saw and you're here at the end, so you probably did. Again, click like, subscribe, and get notifications, and we will, of course, let you know every time we post something to the channel. The next GeoStrata Extra has just been announced this week. That'll be an article from the October-November issue on geotechnical product development. And it'll be editor Chris Woods interviewing Matt Glisson from the Deep Foundations Institute and Tony Marinucci from our Deep Foundations committee, but also from Google. So you will want to sign up for that one. It's going to be October 24th at 2 p.m. Eastern. It's up on our Eventbrite page with all of our other live streams, including we are a week and a half from Terzaghi Day 2023. You do not want to miss that. We will have Professor John Burland from Imperial College London joining us. He is the guy who saved the Tower of Pisa about 25 years ago, and he's also an amazing geotechnical historian. So you want to be here to hear his thoughts on the legacy of Karl Terzaghi. We're going to have a fun day. Again, that's October 2nd at 2 p.m. You'll want to sign up for that on our Eventbrite channel as well. So thanks, Susie. Thanks, Bill, for doing this today. Everybody go check out the issue of GeoStrata that this was in, but from 2021, as well as the current issue. And we will see you with another Geo-Institute live stream in less than 2 weeks.